All right, and this is problem set 15, I think. So this first one is just derivative practice with our quotient rule there. It's going to take a little bit of manipulating to get it into that form, but I'm confident we can do it, so let's go ahead and give it a go. It says if g of t equals this here, then the derivative of g of t is in this form. We just have to figure out what that is, right? So we know our quotient rule is this low d high minus high d low over low low. So we've got our low term. So I'm going to go ahead and write g prime of t. We've got our low term, so it's t plus 2 squared times the derivative of our high term. And while this is chain rule, I see that the derivative of my inside is just going to be 1, because the derivative of t is 1. Derivative of a minus 3 is 0, right? Because it's a constant. So it's going to be 1 times 2, because it's a constant coefficient, so it's just 2. And then minus high, so minus 2 times t minus 3 times the derivative of our low term. And same deal, derivative of our inside is 1, so it's just 1 times the derivative of our outside, which is product rule. Bring that 2 down, 2 of our inside. Okay, and I am going to leave it in terms like this. You could, realistically, you could like distribute this out and FOIL this out as well before starting to take the derivative, but for simplicity's sake, I'm going to keep it in terms like this because I think it's a little easier for us to see what we can and cannot cancel out here. And that's all over low, low. So the bottom squared, it's already squared, so now it's squared again. And I see I've got t plus 2 at the bottom, and I've got t plus 2 attached to all of my terms. So I can go ahead and factor that out. I get a t plus 2 times, I've got t plus 2 times 2, right, because it's just one of these, minus 2t minus 3 times 2. So I could actually change that. I could bring that in front. Okay. Oops. That's t plus 2 to the 4th. I can cancel out one of those. And so it turns into a 2 times t plus 2 minus a 4 times t minus 3 all over t plus 2 to the 3rd power, because we canceled out 1 from that 4th power. And we're a lot closer to this form now, but we're not there yet. So now we want to distribute and combine like terms in the top. So it's going to be 2t plus 4 minus 4t plus 12 all over, same thing, equals, and then combine like terms, it's going to be a negative 2t plus 16 over t plus 2 cubed. I need it to be in a form where it's a t minus something with a coefficient on the outside, so I'm going to factor out a negative 2. So it's going to be negative 2, and then it's t minus 8. Boom. There's our derivative. I'm going to rewrite it over here so we can see it nice and clearly. Oops. Okay, and that is in those exact same terms. It's in that same form. We see that A is a negative 2, B is 8, C is 2, and D is 3. Now we want to do the same thing with that second derivative. So I'm going to take this, same rules, low d high minus high d low for low low, use that quotient rule. And we're going to just manipulate it the same way to figure out that second derivative. So we've got a low term, so it's t plus 2 cubed times the derivative of our high term. This time it's going to be 1 times negative 2, okay, minus high d low. So minus negative 2, I can go ahead and swap that sign there, times the derivative of our low term. all over the bottom squared. And t plus 2 cubed squared is going to be t plus 2 to the 6th, right? Because of our exponent rules, these multiply. And now, once again, I see I've got a t plus 2 term in all of these. In fact, I've got a t plus 2 squared connected to all of my terms, so I can go ahead and factor that out. And that's going to be negative 2 times the remaining t plus 2, since this one's cubed, right? And then plus, well, I've got 2 times this times 3. So 2 times 3 is 6 times this. And this is being factored out, so we don't include it. All over, oops, t plus 2 to the 6th. Cancel 2 of those out. It turns into negative 2 t plus 2 plus 6 t minus 8 over t plus 2 to the 4th, because we canceled out 2 of them. And now, once again, distribute, combine like terms, and then possibly factor out again. So I'm going to rewrite it over here with that distributing. I've got a negative 2t minus 4 plus a 6t minus 48 over t plus 2 to the 4th, which is then a 4t minus 52 over that. And again, we just have to factor something out. So we've got a coefficient in front, and we're going to factor out a 4. So 4 times t minus, let's see, 26, 13, I think. And boom, there's our answer, where E is 4, F is 13, G is 2, and H is 4. Boom. Let's take a look at number 2. We are given that f of x equals this function here, and we want to figure out at what values does the derivative of this function change from positive to negative and from negative to positive. Okay? And all that's really asking is essentially like, what are our critical points, and what are they doing there, right? Because if I have a function that goes like this, right, where it's increasing and then it's decreasing and then it's increasing again, these x values are going to be my critical points, right? Well, when it's increasing, my derivative is positive. When it's decreasing, my derivative is negative, right? So if it's changing from positive to negative, we're going to be at a maximum, because it's going from this positive to this negative. And when it's at this minimum here, it's going from this negative to this positive. So we're just going to look for our extrema and look at that behavior there. So first step is to take our derivative, which is nice and easy. It looks like it's all product rule here. So 4 times 2, 8x cubed, minus 2 times 8, 16x. That's a constant, so it disappears. So here's our derivative. And well, we know that in order to find our critical points, and subsequently our extrema, we need to figure out when our derivative of the function equals 0. So I'm going to go ahead and factor this out really quick. So it's going to be an 8x times x squared minus 2. Okay, and that's going to equal 0 when, well, I know it's going to equal 0 whenever x equals 0. And I see that an x squared minus 2 is in there. So I'll set that equal to 0. So x squared equals 2. So x equals plus or minus square root of 2. So these are our critical points. So now, essentially, what we've got here is there's 2 ways we could think about this, right? I could just go based off of our regular stuff, and I could do, I could set up these intervals and evaluate a value within them to see if it's increasing or decreasing on that interval, and then kind of figure out where those local maximums and minimums are. Or I could just take these 3 points that I found, I could do the second derivative test to see if they're maximum or minimum at that point, right? So if I take the second derivative, that's going to be 24x squared minus 16, right? And so I could just plug in negative square root of 2 into that and see what happens. I could plug in a 0 to that, see what happens, and plug in a square root of 2 and see what happens. And I mean, that'll help us kind of picture what's happening. Or again, I could just find a point on here, plug it into that derivative, see if it's increasing or decreasing, right? I'm going to use the second derivative test here just because it's a little quicker since I've already taken that derivative. If I plug in negative square root of 2, well, that's going to be negative square root of 2 squared, so it's going to be, oops, let me just write that out. So it's going to be negative square root of 2 squared, which is just 2. 2 times 24, 48 minus 16 equals 32, which is positive. And I'm going to just make a note of it up here really quick. When our second derivative is greater than 0, that's a minimum. At a point, that point is a minimum. When the second derivative is less than 0 at a point, that is a maximum. If it's equal to 0, then we have to use some other test to find it, or it's not an extrema. So since this is positive, it is greater than 0, so this is a minimum right here, which means that there's a minimum, so it's going, so that means that this has to be decreasing, and this has to be increasing, right? Because the minimum looks like this, decreasing, increasing. There's our minimum right there, okay? Let's do that for our next point. So I'm going to plug in, I'm going to plug in 0 to my second derivative. If I plug in 0, because 24 times 0 is 0, minus 16, which is negative, and therefore a maximum. So there's a maximum here, which means that I'm then right up here at x equals 0, and then I'm going to decrease again. Okay. And then if I plug in my positive square root of 2, well, that's going to be the same as the negative square root of 2, actually. So I'm going to get 48 minus 16 is 32, which is positive. So again, we have another minimum, which means I'm then increasing, right? Because we've got x equals the square root of 2, and then it goes increasing again all the way up to positive infinity. This also helps us get a good picture of our end behavior, right? So if I was to graph this, I know that it's going to look something like this, where as it goes to negative infinity, it's going up and up forever, and it goes to positive infinity, the same thing. Yeah. So now I see that it's going from negative to positive, right? From decreasing to increasing at this point right here. So when x equals negative square root of 2, it's going from decreasing to increasing. And the same thing with our regular square root of 2. It's going from decreasing to increasing at this minimum. And it's going from increasing to decreasing, so from positive to negative, at x equals 0. Again, you don't have to use the second derivative test for this, but it is just another way to do it, and that's probably how I'm going to be doing that for other problems in this as well. But again, you could figure all this out just using the first derivative, and that's actually how I did it on the homework when I was giving it a first go. But later questions do specifically tell us to use the second derivative test, so it's a good habit to get familiar with. This is a similar question, except now we're working with a trig function. So our function is cosine of x plus x over 2. So we want to know when our derivative is changing from positive to negative. So from positive to negative, we're looking for when it's at a maximum, right? So first thing we do is take that derivative. And the derivative of cosine of x is a negative sine of x. And now the derivative of x over 2, well, that's just a 1/2 times x. Derivative of x is 1, so it's just 1 times 1/2, or just 1/2. So there's our derivative. Again, we want to find our critical points, so we want to know when this function equals 0. Well, I know that this will all equal 0 whenever negative sine of x is equal to negative 1/2, right? Because it's going to cancel out with that. So I need to know whenever sine of x equals 1/2. So when does sine equal 1/2? Well, it equals 1/2 at a couple points. It equals 1/2 right here at pi over 6, and right here at 5 pi over 6, right? So we'll use those as our first two critical points, or as our main critical points, and see what's happening there. So again, I've got these intervals. I've got negative infinity all the way up to pi over 6. I've then got from pi over 6 to 5 pi over 6, because remember we travel along our unit circle like this, counterclockwise. And then I've got from 5 pi over 6 to infinity. And I'm going to use the second derivative test for this, I think. So our second derivative is going to be a negative cosine of x. And this is a constant, so it disappears. So this is our second derivative. If I plug in pi over 6, I know cosine at pi over 6 is square root of 2 over 3. Square root of 3 over 2. Which is positive. Remember that if it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. I know that kind of feels the opposite of how you want it to be. And honestly, knowing that it feels the opposite of what it should be, of what it is how I remember it, because it's unpleasant. But since this is positive, I know that there's a minimum happening there. So I know we hit a minimum, which means I'm decreasing and then increasing, which means I'm going from negative to positive. But we want to know when it's going from positive to negative, right? So let's try plugging in our other one now. So plug in that, and the cosine at that point is a negative square root of 3 over 2. Oh, and I made a mistake because I'm plugging those into cosine, but our second derivative is negative cosine. So I actually mixed up these two. So if I plug in pi over 6 to cosine, yes, it is square root of 3 over 2, but this is a negative cosine, so it's a negative square root of 3 over 2, which means that this is not increasing, this is not decreasing, but the opposite. This is increasing, this is decreasing, and we have a maximum here. Just to double check though, I do want to plug this in, see what happens. We're going to get a positive because that negative cancels out. So we've got a minimum. That makes sense, right? That's going to look something like this, with this being pi over 6. So it's going from positive to negative at x equals pi over 6. And is that one of our options? Sure enough. Let's take a look at number 4 now. Same thing really, determine the relative extreme values of the function. So we want to figure out if there's a relative maximum, where it is, and relative minimum, where it is. Okay. Again, first step, take that derivative. Okay. And then set that equal to 0. So 12x plus 30 equals 0. That means 12x equals negative 30. X equals negative 30 over 12. And I can reduce that to a negative 10 over 4, negative 5 over 2, I think. I think that is correct. Yeah, should be negative 5/2. So we only have one critical point, and that is when x equals negative 5 over 2. So we can only find a relative maximum or a relative minimum. One of these is not going to exist because in order for both of them to exist, I would need at least 2 critical points because otherwise we've just got 1 point and then our end behavior. That being said, I could now use the second derivative test to figure out if this is a maximum or a minimum, or I could go how we've been doing and do the whole negative infinity to here, and then here to positive infinity, and then plug in a point on these to figure out if it's increasing or decreasing with that, right? I am going to use our second derivative test though, just because it's really easy here, because our derivative our second derivative is just 12, which means that it's, oh, well, I don't like that actually, because I feel like that, I feel like I've made a mistake somewhere, but let's, just in case, I'm just going to use this way actually. Sorry. So I know that negative 5 over 2 is the same as negative 2.5. So let's try plugging in a negative 3, right? So that it's on this interval. So the derivative of f(x), if I plug in a negative 3, that gets me a negative 36 plus 30, which is a negative 6, which is decreasing, right? Because it's negative. And then let's try just plugging in 0 is really easy. And that's on this next interval. And that's just going to be 30, which is positive and increasing, which means it goes decreasing, increasing, which makes this a relative minimum. So we don't have a relative maximum because this is infinity and this is infinity. So these do not exist. But our relative minimum is at negative 5 over 2. And now we have to figure out the actual value of it. So let's plug that into our original function. F of negative 5 over 2 is 6 times that squared. That's going to be 6 times 25 over 4 plus minus, because of the negative, minus 30 times 5 over 2 plus 4, and I can turn that, that's going to be 15 times 5. Okay, so 3 times 25 over 2, and I'm just kind of simplifying this as I go so I can do it a little easier in my head. 15 times 5 plus 4, and that's all going to be 75 over 2. Minus, let's see, 50 plus 25 is 75 plus 4. Okay, so that's going to be, it's 75 divided by 2. 30, 35, 37.5. Okay, minus 75, that's going to be negative 37.5. Plus 4, it's going to be negative 33.5, I think. And there. There's a chance I made an error in there, but we're just gonna continue on because the minute details of like the actual answer here isn't important so long as the process makes sense. Let's try number 5 now, and this one actually instructs us to use the second derivative test. So we want to find any critical numbers and figure out our relative minimums and maximums if they exist. So take that first derivative, that's going to be 9x squared plus 54x, and then I'm going to go ahead and take my second derivative since I know we're going to use it. That's going to be 18x plus 54. Okay, and we first determine our critical numbers, critical points, by setting our first derivative equal to 0. I can factor out a 9x there. So I'm just going to rewrite that really quick, just so it's a little easier. Okay, so this is just this factored out a little bit, and I know that that equals 0 when x equals 0 because of this, and when x equals negative 6 because of in here. So those are our critical points, and then if I plug 0 in to my second derivative, that is 54. When I plug in negative 6, I can tell that that's going to be less than 0 because I can tell it's going to be negative because 6 times 18 is going to be way bigger than 54. Remember that when it's greater than 0, it's a minimum. When it's less than 0, it's a maximum. So at x equals negative 6, I have a maximum. So I have a maximum here And I've got a minimum here. Oh, here probably, because 0 comes after our -6, which is actually why I like to write those intervals, just because it gives me a better idea of where things are happening, right? So here I can see pretty clearly. If this is a maximum, that means I'm increasing, decreasing, and then I'm increasing again since this is a minimum. So I have a minimum at f of 0. And if I plug that into my original function, the value is 4. I have a maximum at f of -6, which, ooh, this is a little ugly and has me a little nervous, I won't lie. Okay. I'm just going to use a calculator to make this quick. Okay. So plugging into that is that, plugging into that is at those. And I can tell it's definitely positive, so we're on the right track. And that's +4 minus, and that turns out to be this. And there we go. Let's try number 6 now. We're given this function, and we just want to know on what intervals is the function increasing and on what intervals is it decreasing. Okay. All we need for this is our first derivative. We could use the second derivative to see if there's any maximums or minimums, but we'll just use the first derivative for this one. And the derivative of e to the x is just e to the x. And this is a constant coefficient, so it stays that way. And this is a constant, so it disappears. Okay, so this is our derivative. And this equals 0. Never. Oh, you know what? I set up the question wrong. That should be a 2x. Sorry. My bad. I forgot that part. So this is our function. If we take the derivative of that, it is this. There we go. And that equals 0 when x equals 0. Because at x equals 0, we have e to the power of 0, which turns into a 1, times a 2, minus a 2, which is just 2 minus 2, or 0. So this is our only critical point. So we've got -infinity up to 0, and then 0 up to infinity. And now I'm just going to plug in a -1 for this interval, just to see what that looks like. So 2 times e to the -1 is the same as 2 over e. And then I'm going to plug in a +1 for this interval, which is just 2e minus 2. For this one, I know that 2e is bigger than 2, so 2e minus 2 I know is going to stay positive, right? It's going to be greater than 0. So I know we are increasing on this interval. But for this one, because it's a 2 divided by e, and I know e is greater than 1, this is going to be smaller than 2, which means that subtracting 2 is going to make it less than 0, which makes it negative and decreasing, which means, well, I suppose we don't need to determine the minimum maximum. We just found what intervals they're increasing and decreasing. It's increasing from 0 to infinity, and it's decreasing from -infinity to 0. I think we've just got 2 questions left. Yep. So this first one, we are given this function. We want to use the first or second derivative test to find the relative extreme values for the function. And then we need to identify the end behavior of the function. So the behavior of the ends, or the tails, as it says. So first off, we're going to take that first derivative, which is going to be 60x minus 24x cubed. Okay. And I think I'm going to use the second derivative test for this one. So I'm going to go ahead and take that second derivative as well, which is just 60 minus 72x squared. Okay. And I am, for both of these, actually going to factor it a little bit just so it's a little easier to handle. Okay, I'm going to rewrite that as well. Probably the same type of factoring. Okay. I think that, yeah. Okay. So now we need to determine our critical points. Well, our critical points are whenever this equals 0. So f prime of x equals 0 at x equals 0 because of this bit. And then I've got a 5 minus 2x squared, set that equal to 0. Negative 2x squared equals negative 5. X squared equals 5 halves, which means that x equals plus or minus the square root of 5 over 2. So those are all our critical points, those 3 points there. So now we'll plug each of those into our second derivative and see how it goes. The second derivative of 0 is 60. Second derivative of negative square root of 5 over 2 is 60 minus 72 times 5 over 2, as is the second derivative of a positive square root of 5 over 2. It looks like both of these are going to be less than 0, and this is greater than 0. Remember, second derivative greater than 0 is a minimum, and second derivative less than 0 is a maximum. So let's see, I've got a maximum here, so it's increasing up to here, and then it's decreasing to my minimum of 0. And then it's increasing again to my next maximum, and then decreasing to infinity. So our relative maximums are these. I have a relative minimum at x equals 0 and no others. So I'll say that this does not exist. And now I just need to figure out what these points are. So I'm going to plug those into my original function. F of negative square root of 5 over 2 is then a 30 times 5 over 2 minus 6 times whatever this is squared, which is then 25 over 4. Okay. So this is now 15 times 5 is 75. So it's a 75, and that's a 2/3 times, oh, no, 3 times 25 over 2 is 75 over 2, and I already figured out that's 37.5. So it's minus 37.5, which is just 37.5. Okay. And because these are even powers, I know that this maximum is going to be the same, since these are just the positive and negative of one another. So these even powers end up getting rid of that negative, so they end up being the same. And now I'm just going to plug in f of 0, and that gets me minimum at 0. And boom. Now I just need to figure out our tail behavior, which we kind of already sketched out here. I know that as it goes to negative infinity, it's going down. As it goes to positive infinity, it's going down. So it's going to be this one here. And now number 8 is the same type of question, but a different function. Yeah, I got lazy. I wrote just the same instructions as previous question. So we're going to go ahead and take that first derivative, which is a little trickier. I think I'm going to go ahead and distribute that out first. So I'm actually going to, let's see, that's going to be x squared plus 8x plus 16 all times 6 minus x. This is where it gets trickier, so I have to draw out my lines to help me. Okay, that's the same as 6x squared plus 48x plus, let's see, it's 64 plus 32 is 96. Okay. Minus x cubed minus 8x squared minus 16x. All that equals negative 2x squared. Oh, standard form. So negative x cubed, negative 2x squared, 48x minus 16x is a 32x plus 96. Okay. Now if I take the derivative, it's a little easier. So it's going to be negative 3x squared minus 4x plus 32. And then if I take my second derivative, because I do want to use that as well, it's going to be negative 6x minus 4. Okay. So now I need to figure out when this equals 0. And this doesn't look like this factors out. We might need to use quadratic formula, which is not my favorite. Let me just see that it doesn't factor out though. So it's going to be negative 68, negative 4, da da da. This is how I learned to factor, so. $15, $16, $17. I believe 17's prime. Yeah, so it doesn't look like we can really factor this out. So I guess we'll use the quadratic formula to figure out our zeros for this function. Okay, so remember quadratic formula is this here. So that's going to be 4 plus or minus 16 plus, what is, oh god, 4 times 32, that's 120 plus 8, so 128, and then 128 times 3, I know 2 of that's going to be 256, so then just plus another one is 384, and then over 2a, oops, okay. Now 384 plus 16 is just 400. Oh, that's a nice pleasant square root at least, because square root of 400 is 20. Which means that this is a negative 24 over 6, which is just a negative 4, or it is negative 16 over 6, or negative 8 over 3. Right, 384 plus 16 is 400, right? I just need to double check that. Okay, perfect. Perfect. So these are our extrema. So our critical, or not our extrema, sorry, but our critical points are negative 4 and negative 8/3. Now, just plug those into our second derivative equation. So I'll use negative 4 first. Negative 4 times negative 6 is 24, minus 4 is 20. And then second derivative of negative 8/3 is 48 divided by 3 is 16, minus 4 equals 12. Well, that looks like they're both minimums. Does that make sense? So I've got from here to here, got from here to here, and from here to here. I'm gonna use this to double check really quick. So let's see, something on here is maybe a -5. So I'll use that. So it's gonna be -3 times 25, which is a -75, plus 20 plus 32 equals a negative number. So it's decreasing. If I plug in -8/3 is the same as -2 2/3. So I'm going to plug in a -3 here for this interval. That's going to be 9, -27, plus 12, plus 32. That's positive. So that's increasing. So there's not a minimum at that point. That doesn't make sense. So I might have to redo something. And then I'll just plug in a 0 there, which is then just 32, which is positive. Okay, so it's decreasing and then increasing and then increasing some more. All right. Well, it doesn't look like this is actually a relative minimum per se. This is not how the one on the homework went, so it's throwing me off a little bit. I'm not super sure what to consider that. I'm gonna assume that something weird's happening there. It's possible that I just made an arithmetic error somewhere, but I don't know that I'm up to figuring out where that is. So we're just going to consider it as such and say that there are no relative maximums for this one, although there might be for your problem on the homework, so be careful. And we'll say that our only relative minimum is at -4. And that our end behavior is this one. No. This one, because it's like this. And then we just need to figure out what f of -4 is. -4, plug it into this up here. And that is 0 because of that. And boom. There's our last question for this one. I hope this one was a shorter one, but it's a little bit different. This is a pretty new topic, I feel like, for a lot of us. But it doesn't seem like it's too terribly different from what we're used to, so I hope that a lot of this made sense. And if I made any mistakes, feel free to let me know in the comments or message me directly. And yeah, I hope this was helpful. Thank you for watching.